Okay, I'm going to explain how to find the approximate solutions to this equation. Step one is to use a bit of trial and error, but your goal here is simply to find two numbers that this has a solution in between. And so your goal is to bear in mind that you want your value of x when you substitute for x to give 0. So if you can find a value of x that will give a positive, and you can find a value of x that will produce a negative, then you can reason, as long as the graph can be drawn without taking your pen off the page, or in other words, if the graph is continuous, then you can reason that there must be a solution in between. So the question will almost always tell you what to use. So this question would say use the number 1. Work that out. So that's 1 plus 3 is 4 minus 5, so that's negative 1. So not 0. We want it to be 0, but we've got negative 1. Then the question would say try 1.5. I can't immediately bring to mind what that will be, but let's say it's 1.7. And what you do is you now point out that you've succeeded. So you say negative, you say positive, and you say therefore solution between 1 and 1.5. So that's the first step. Now the second step is to change perspective so that you're no longer trying to get 0 when you substitute x, but you're instead trying to get the same number back again. So for example, putting in a 2 and getting a 2, putting in a 3 or getting a 3 back again. So what you have to do is you have to rearrange this until you have x the subject, but instead of no appearances of x on the other side, you want there to be at least one appearance of x on the other side. Now they'll almost always tell you what to make it look like, but I'll just show you what would involve here. So let's say we first do a red dude of adding 5 to both sides. Now I do a red dude of taking x squared out as a common factor. Now I do a red dude of dividing both sides by x plus 3 in a bracket. And now finally I do a red dude of square rooting both sides. And so this is exactly the switch of perspective I meant before. Here, you know you've done the trick if you substitute in x and get a 0. Here, you know you've done the trick if you substitute in a number for x there and you get the same number again, which you almost never will. So for example, if I put the number 1 in there, we already know that that's not a solution because it gives negative 1. If you put the number 1 in there, you get 5 over 4, which is 1.25. You square root that, you definitely don't get 1 again. Anyway, that's part B. Often this will be part A. And your third step, which will now give the solution, is to use that. Now what they'll do is they'll tell you what number to start with. It'll almost always be one of these two. So for example, your first thing is to try 1.5. That's if I was told to use that first. And you work that out and you get an answer. I don't know what that's going to be. Let's say it's 1.12. And often in the working they'll call that x naught, because this is the beginning of a journey, which is why this is called iteration, for finding an approximate solution. Now what you do is you type the thing again, but don't use 1.5, use what you just got. And don't type it out again, just use the answer button. So you literally do this. And then record what you get from that. And so let's say that's 1.06. That's the next stage in the journey, called x1. And now the calculator is so designed that if you literally just keep pressing the answer button, it will treat it as if you typed that out again, but with your new answer where the answer button was. And the idea is that if your goal was to put a number into here and get the same number back again, you know that you'll have the answer when what you substitute in matches what comes out, which it doesn't here. or what you substitute in matches what comes out, which it doesn't here. So anyway, you just keep pressing the answer button. It takes 5, 6, 7, maybe 10 times until you start seeing that the answer is settled down. So if you wanted the answer to 4 significant figures, and you see that's that, then it's this, then it's this, then it's this, then it's this, with only these digits changing, but with these staying the same, then you can be confident that one answer is 1.067 to 3 decimal places, or 4 significant figures.